Well, about a week ago, as I record this, a condominium collapsed in Miami on Miami Beach. And as we record this, it looks like there are something like 20 people confirmed killed and still something like 150 missing. Virtually all of those people are going to move from the missing column into the killed column in the next several days. It's been a particularly difficult site to excavate because the collapse of the building resulted in pieces that were really kind of incredibly fine, small. You might think that that would be lucky, but it's actually just the opposite. In a building collapse, the only people who have a chance of surviving are people who are trapped in what are called voids, where large pieces of debris, just through sheer roll of the dice, happen to form kind of a shelter for survivors trapped inside. There's been no audio sounds of survivors, nobody tapping on walls, and it looks like, especially after this much time, that all of the missing are going to be confirmed dead. Now, a lot of us are wondering, well, how can that happen, especially here in America? Now, that particular building on Miami Beach is one I'm relatively familiar with. I worked in a nightclub on Miami Beach for 3 or 4 years in the late 80s, and I must have driven past that building 300 times in the course of my life. That building collapsed because of a known structural defect, and that's what I want to talk about today. But before we talk about that structural defect, I'd like to use a different example that's a little bit more glaring, and since it happened quite a while ago, we know a lot more about the details. On July 29th of 1999, the Champlain Mall in Seoul, Korea, collapsed. The actual numbers never were found, but they suspect some 500 people had died in that building collapse. Let me tell you a little bit about the Champlain Mall. It was being built for the 1998 Olympics in Seoul, and the South Koreans had passed legislation saying that no outside firms could be used in the construction. So the Korean firms were making a lot of money, but they were very, very, very overtaxed and under capacity. This building, the Champlain Mall, was built on a landfill, and during the initial investigations, they suspected that it might have been this landfill, this unstable foundation, that might have caused the collapse, but that's not what they found to be true. What they found to be true was that the company that did the original engineering on this, called Woosung, had done an extraordinarily thorough and professional job of excavating the landfill, going right down to base rock, and they built a foundation that was as good as any foundation in the world. They were professional engineers, took their job seriously. And they built the 4 floors of the foundation, this Woosung construction company. But as the building was going up, the management, the owners of the Champlain Mall, started to make changes to the architecture. They began to make so many changes that the company that built the foundation, Woosung, simply said, we're not going to be a part of this. We have built the foundation, our contract is canceled, we're not going to build that building, it's unsafe. How unsafe was it? Well, the Champlain Mall was originally designed to be a 4-story office complex. And it used a kind of construction called flat slab construction, which consists of basically concrete floors. There's no reinforcing steel beams or anything. And there are a series of columns that are spaced throughout these floors that support the weight. And for an office building, that would have been fine. But the reason Woosung walked off the job was because the company, after having built the foundation and delivered the blueprints, started making changes, as I said. One of the first changes they made is to turn this office building into a shopping mall, which meant that they took out an entire atrium. They wanted that big, huge, open atrium space that's so attractive for shopping malls. So that's what they did. They simply took the middle of the building out of the building. That reduced the load-bearing capacity of the building significantly, as did escalators that had been put in after the fact. And then, as the building was going up, and South Korea and Seoul especially was just booming economically, the guys at Champlain decided they were going to add another floor to this building. That was not in the original plans, was never particularly taken into account during the initial engineering analysis. They added another floor. This building was in such trouble from the beginning that the noise of the air conditioners so enraged the local neighbors that they moved the air conditioning units, these huge, heavy, enormously heavy things, up to the roof of the building, which put even more weight on a 5th floor that wasn't supposed to be there in the first place. Now, they could have hired a crane, of course, to just lift these units and move them over, but that would have been a little more expensive than the labor force they had. So they basically just pushed them across the roof, get them away from the edges and into the center where they might be quieter. This mall had developed cracks from the very beginning. In some of the restaurants and some of the kitchens, there were enormous bumps, like speed bumps, where the structure was basically, the floor was essentially settling around the structures, what was happening. And then, as I said, on July 29, 1995, the building collapsed. But here's what's especially interesting about this case. On July 29, 1995, a team of professional engineers not hired by Champlain went into the mall, took a look at the obvious cracks everywhere. I mean, the entire building was simply cracked and falling apart. Everywhere there were cracks, everywhere. And these engineers went to the building managers on that day and said, you got to get people out of this building. You got to get them out of there right now. Champlain owners said, well, we disagree. One of the reasons they disagreed was that the mall was doing over $1 million in retail sales in Korea in 1995. That was real big money. So the executives evacuated the building, but they didn't shut the building down. And then the building collapsed. This collapse in Miami was a result of an identical structural defect. And you think, as I've hoped you've come to think, that the structural defect is an engineering problem. But that's not the structural defect I'm talking about. The structural defect that cost the lives in Korea and the structural defect that cost the lives in Miami is the exact same structural defect that cost the lives of the 7 astronauts on board the Challenger and the 7 astronauts on board Columbia. It's the same structural defect that caused the Titanic to sink with so many people. It's a structural defect that's built into the human heart. And the structural defect works something like this. We know we have a problem. The problem hasn't happened today. It's going to cost us to take care of the problem, and so let's take care of the problem tomorrow. That's it. That's all there is to it. It's an engineering design flaw in the human heart. It's not in the buildings, not in the airplanes, it's not in any of that. It's in the human heart. And the reason this is an engineering defect is because in this case in Korea and in the case in Miami, the building was known to be in need of major structural repairs. Last I heard on the building in Miami was that they had not sufficiently waterproofed the structure, and the corrosive salt air, which is just a couple yards away, had gotten in and started to corrode the rebar, which is basically keeping the concrete under tensile strength, and the next thing you know, the whole building collapses. And something like 150, 160 people are going to pay for this with their lives. When you start to analyze this structural defect the way an engineer would analyze any other failure to prevent it from happening in the future, we can identify a couple of things that are common towards this kind of thing. Obviously, the major contributing factor is that it didn't collapse today, so it probably won't collapse tomorrow. We flew any number of shuttle missions with burn-through O-rings prior to Challenger exploding on takeoff. But they hadn't caused the loss of the vehicle before, so chances are pretty good it wouldn't cause the loss of the vehicle today. And like with the Champlain Mall, by the way, engineers on the scene at NASA during the Challenger launch were running around screaming at the top of their lungs saying, don't launch this thing. Don't launch it. It's going to be a catastrophe. They launched it anyway. Why? Well, because there had been a number of delays on Challenger flight, and it was carrying the first teacher in space, and there was political pressure for NASA to get this person up there. And like I said, it hadn't exploded before, so it probably won't explode today. And that's true. It didn't before, so it probably won't today. In all of these cases, there was warning. Miami structure in 2018 was inspected and found to have serious, critical structural problems that needed to be addressed right away. When we get to the Miami building, what we find is that it was a condominium. And as Scott Ott pointed out, we had this discussion on the Backstage show for Right Angle. We didn't do the segment because I wanted to talk about it today. But Scott pointed out that it wasn't a hotel, it wasn't an apartment complex, it was a condominium. And this is different because a condominium is owned by the people that live in it. And what that means is, if it was an apartment complex and you lived in an apartment complex and you saw these cracks in the wall and you saw these structural defects in the building you and your family were living in an apartment complex, you would be in a major hurry to have the landlord make these repairs And if he didn't, you'd be on the case with the press and the cops and building inspectors and whoever else. In the case of a condominium, however, the cost of the repairs, apparently now, the cost of the repairs would have to be borne by the people who actually live in the building. And the last estimate that we heard was that these repairs to this building would have cost $15 million. So now picture yourself as one of these people living in this building. As I said before, I know this area pretty well. Miami Beach can be very glamorous, but Miami Beach, much like a lot of these buildings in Seoul, was put up in a hurry. In the 60s, when everybody was moving down there, they were just building these buildings left and right. Probably originally was an apartment complex, I'm sure. These rather hastily built structures became essentially relatively, and I'm talking relatively low income condominiums compared to the stuff that's right on the water and it's much newer. So I say all this only to say, here's how we can analyze this failure and realize that the people who lived in the building almost certainly, well, without question, they knew that the building was in trouble. But at the same time, if you take $15 million and divide it among 160, 200 people, that's not an insignificant amount to pay. And so their financial interest, I'm not blaming the victims, I'm just saying this is how the mind works. We want to understand the nature of the flaw in the human condition. So they figured, well, it didn't collapse yesterday, and we'll probably get to it in the summer. Well, they didn't make it to the summer. The Titanic sank because of a very simple reason. White Star, owners of the Titanic, was locked in a life and death struggle for the very lucrative transatlantic trade in the early 1900s. And their main competitor was Cunard. Cunard lines were not as big as the White Star liners, but ships like Cunard's Lusitania were known to be very fast. They were the fastest passenger ships on the water. And on the maiden voyage of the Titanic, Captain Smith was not only under his own pressure for his own ego, it was his last trip, would have been his last trip even if it hadn't been his last trip. But the White Star owners pushed him to make this crossing in record time. And that meant sailing into a known ice field at top speed, as fast as she'll go. He knew the ice was out there, and he knew that the owners and he himself wanted to set this record. And ice hadn't sunk anything he'd been captain of before, so chances were pretty good it wouldn't sink it tonight. And as it turns out, chances were pretty good that it wouldn't sink tonight, but sometimes that odd chance comes up. Pilots, people in aviation, not only take a certain amount of risk when they're flying, they take it all the time. They take it multiple times a day in many cases. And so there is a very strong motivation, not only financial, but also for the people involved with the actual operation of our commercial aircraft system to learn from the mistakes of others. When I was a flight student, they said, kid, you better learn from the mistakes of others because you're not going to live long enough to make them all yourself. And in aviation, we are astonishingly honest, astonishingly forthright, and absolutely fearless when it comes down to understanding what happened. Why did these people die? Why did this plane crash? And also to the credit of American commercial aviation, regulations are put in place to make sure that what happened that particular time will not happen again, at least if the rules are followed. We don't know what we don't know. And many of the things that end up causing airplanes to go down are things that we hadn't realized before. But once it happens, we do something about it, which is why in the United States, we are approaching, in September, the 20th year of commercial aviation in this country, which averages 40, 50,000 flights per day in America, without a single crash of a major U.S. carrier. Not one. Because we learned from our mistakes. The buildings in Korea after the Champlain collapse, turned out that they did an audit on those. 4% of the buildings in Seoul, Korea were up to engineering standards. 18% were considered iffy, and the rest of them were just patently unsafe. So this is the fault in the human condition, and we can be proud of the fact that buildings aren't collapsing all the time. We've gotten very good at this, and the fact that buildings aren't going down all the time says an awful lot about our ability as a species to overcome this engineering defect that we have, this structural defect in the human heart. Which brings me to the main point of this whole thing today. I've had to make this kind of a video probably twice or three times in my entire career, and it's time again. This structural defect is in every single living person, and you've got it too. There are some of you out there watching this who are experiencing symptoms of some kind of serious illness that you're ignoring. And you're ignoring it because either you don't want to face it, or you don't want to believe it's true, or you don't want to pay for it, or maybe it'll get better, or I hope it's not what I think it is, and so on. In 2011, I found myself with an irregular heartbeat, so I went to my regular doctor. And he listened with the stethoscope. He said, "We'll get you an EKG." So they put me down and gave me an EKG. And he read the EKG and he says, "There's just a little tiny thing here I don't really like so much. We'll give you an echocardiogram EKG, where they're using ultrasound to watch the valves of the heart." He took a look at that and he said, I'm gonna write you a recommendation for a cardiologist." Now you can imagine that I'm not terribly pleased by this procession. Prior to that, by the way, he'd given me a monitoring device, electronic thing, looked like it was probably designed in Bulgaria in 1948. But it was this huge device and had sensors, and it would monitor my heart over a 24-hour period. All these things together, taken by this doctor, got me the recommendation to the cardiologist. He took a look at those strips. He said, "I want you into the hospital now for one of these radioactive tracer dye tests." Okay. So they gave me this radioactive dose of stuff. And by the way, that radioactive tracer material that was in my blood for a while was strong enough to set off the radiation detectors that the hospital has installed so that nobody sneaks away with any radiological material to build a dirty bomb. I walked past a building and all these alarms went off. It was kind of interesting. Anyway, here's the short form. I got into the machine and then I got out, and then they want to get your heart up a half an hour later. They measured the difference between how much blood you're pushing out at rest versus how much blood you're pushing out when your heart is working. And a very sophisticated computer algorithm could say, if the resting rate is pretty close to the active rate, you're not getting a lot of blood out there, you got a problem. So, as I'm getting ready to do the second part of the test, I'm sitting here waiting for the doctor to arrive. I was a little late in traffic, and I'm hooked up to an EKG, a real nice one, and I see 6 different screens. And as I'm sitting there looking at these things, I can see them just going boom, 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 boom. That's not good. So the doctor arrives, and I get on the treadmill. And as I start to work, and as I start to build up a little head of steam here, working faster and faster, my heart's beating faster and working harder, the irregularities just disappeared. They just went away. And being the curious guy I am, I'm on this treadmill saying to the doctor, "That's a good sign, isn't it?" He says, "Yeah, it's a good sign. We'll see what happens." They take me back for the test. I call the doctor a couple of days later. This is a direct quote. I call the office manager and I said, "Hey, I'm just checking up on the cardiac results for Bill Whittle." She says, "Hang on a second. I'll check with the doctor." She comes back 15 seconds later and says, "Yeah, I just spoke with the doctor. He said you're going to live forever, kid. Now don't bother him anymore." Now, they may have come back and said something different, but that's not the point. The point is I did something about it. Just a year ago, during the pandemic, I felt a pain in my left arm. It wasn't what I thought it was, but I wasn't sure. So I went to our doctor, and the cardiologist said, "You're in great shape. For a guy who's 62, your chance of a heart attack is 1 in 1,000. I said, "Okay, I'll take those odds at this age." Why am I saying all of this? I'm saying this because I have heard from people in the past, handfuls of people, but that probably means a few more that didn't write me. I've heard from handfuls of people in the past that when they've heard this message, it's been enough to get them to finally go and do it. So, would you please finally go and do it? There is no advantage at all, none, to not taking care of a problem that you already know exists. And if you're waiting for the building to collapse, it will. You know, those people in the mall and the people on the Challenger in Columbia and the people in Miami didn't have to die. If people had paid attention to the warning signs that had been there from the beginning, that were clear, and that they knew were there, if they paid attention to those warning signs, those tragedies wouldn't have happened. But they didn't. So, if you're afraid of getting bad news, look, it's better to get bad news while you can do something about it than while it's too late. I cannot imagine a worse destiny than to have somebody tell me that I've got some terminal illness that I could have gotten taken care of if I'd gotten to it sooner. Don't stand there and have your relatives wonder why you were buried in this rubble, metaphorically, when you knew that there were cracks in the staircase and that the building's foundations were off and that there were giant, gaps and just don't do it. If you think there's a problem, overcome by force of will the structural defect in the human heart that tells you, well, it's probably not going to happen today. This probably won't happen today, but it will happen. And you will be relieved to know how relieved you will be if you take my advice on this one, and I'm speaking from experience here.